Woohoo! We are live, and this is the Math 75 Chapters 5 and 6 practice test. Yay! And before we get into the practice test itself, let us once again review the difference between a practice test and an actual test. On the practice test, is there a time limit? No, you can take as long as you want. You can have a whole party around it. Are there retakes? Yes, absolutely. You can practice the practice test as often as you'd like. Is it open book or notes? Well, it's up to you. If you want to practice the test as it will happen, you keep it closed notes. If you want to have notes with you, awesome. Open notes, closed notes for the practice test. It's totally up to you. The actual test, 90 minutes. It's capped at 90 minutes. Make sure you finish by then. Are there retakes? No. It's one and done. That's it. Is it open book or notes? No, except I will attach something very similar to this, which will just be a listing, likely not in this order though. This is just a practice one of all of the formulas that we use in chapter 6, so that if you forget one of them, you can look here. You'll notice that I don't name the different formulas, so you'll have to be able to recognize them. The idea behind this is this should match what would happen in the quote-unquote real world, where if you have to calculate something for a client, you could look up a formula, but it's up to you to know which formula is the correct one on site. So you may not remember all the details, and I gotta be honest, when it gets down to some of these are complicated. It's easy to make mistakes, and I don't think the emphasis should be on memorizing these formulas. Your business classes may have other thoughts about this, but for my class, I'm going to give you the formulas, but you have to know what's an S, what's an A, what's an R, what's the difference between when R starts over here and when R is over on the right-hand side. You need to be familiar with them. Okay, so having said all of that, let's get started. Woohoo! Again, the caveat is that as we're going through this practice test, the way that Canvas gives tests, sometimes, hopefully the problems are in the same order, but the answers will be in a different order most likely. So I've just written them up in the order they appear for me, but they might appear for you in a slightly different order. Okay, let's get started. Woohoo! Yay, finance. Okay, first problem, not actually finance. I know that was bait and switch there, but this is a problem from chapter 5, and it's from your homework, I believe. Suppose the demand function, demand, for Q 1,000 units of a certain commodity is given by horrible formula. First question, at what price will the demand equal 5,000 units? So a couple things here. I'm starting right off the bat and assuming you know which is price and which is demand. So remember that P equals price, unless it's a capital P, and that Q stands for quantity, and that's the demand. Remember that sometimes demand is Q and sometimes demand is X, because we talk about the units of output being X. So we've got a couple different ways to refer to it, but in a situation where I'm giving you P and Q, P is price, Q is demand. Okay, next up, we want to know what is price, given that demand is, now here's the tricksy thing, 5,000 units is actually, it's Q 1,000 units right there. Let me underline that with my handy dandy highlighter, because 5,000 isn't going to go in as 5,000, it's going to go in as 5. And that's the important trick to these problems. A lot of them will have specifications in the problem that you have to pay attention to. Okay, so I got Q equals 5. P, I don't know, so let me use the formula. P equals 50 times the quantity 3 to the negative 5 over 2. Okay, since I don't have that number memorized, I'm going to go ahead and get started here. I'm going to do 50 times, oops, you can't quite see that, can you? Come here, Sharktopus. I'm going to move you sideways a little bit. Let's get you. Okay. So how far up can I go? Ooh, I can go all the way up. Okay. So 50 times the quantity, and then I'm going to have 3 raised to the, now remember, don't use a minus sign. That'll confuse your calculator. Find your negative sign. And then I personally am going to put in a 5 divided by 2 inside parentheses. I think this is because I'm just very old and used to very much older calculators than you are. The other way to do this is if you happen to know that 5 over 2 is 2.5, you can always put it in decimal form if it's an exact decimal. In other words, a terminating decimal. Okay, fingers crossed. Let's hit enter. And I get 3.207 and some other stuff. Now for this one, it says round to the nearest cent. So that's going to be 3.2. And then I look at the 7 and I say, oh, it's above 5. So I'm going to raise the 0 to a 1. And let me make these wiggly because it's approximately. 3.21 is right there. Yay! Oh, first one done. 5 points. Yay! Fun fact, when there are 2 parts, Canvas will automatically assign each part half of the points. So if it's 10 points, I don't get any say in it. The first one is 5, the second one is 5. Doesn't matter if the first one's easier or the second one's easier. Canvas will automatically do this. Okay, part B says, how many units to the nearest 1,000 units? Notice I am reminding you about that 1,000 thing. Will be demanded if the price, so here we've got the price is $18.53. Woohoo. Okay, and I want to know what the demand is. Okay, so what in this case, I'm going to take my formula. P equals 50 times the quantity 3 to the negative Q over 2. And I'm going to put the 1853 here on the left where the price is. And then I'm going to think, oh no, what am I going to do? And the answer is, well, if you've got a variable hiding up in an exponent, you're going to have to use a logarithm. And so you're going to have to choose whatever your favorite logarithm is. Some people like common log, some people like natural log. I mean, you could like log base 1.7, whatever logarithm you want to use. It's going to depend on what kind of a calculator you have, how much freedom you have. For basic calculators, basic scientific calculators, you've got common log or natural log. And a lot of people like natural log because it's 1 letter shorter. So first things first, though, I have to get rid of the 50. So I'm going to divide both sides by 50. So I get 18.53 over 50. Now, some people want to write that out as a rounded decimal. Do not do this, because when you round in the middle of a problem, you end up losing precision. So don't do that yet. Leave it there. I know it's annoying and awful, but we will survive. Trust me. Okay. Now, as soon as you've got your exponent clear of anything around it, you can go ahead and take a logarithm. I'm going to use common log because I think it's pretty. I know that's a probably a very silly reason to use common log, but I just like it. Okay, and then I'm going to grab some more calculators, some more paper. Switch over to some scratch paper. So this is number 1B. I've got the logarithm of 18.53 all over 50 is equal to log of 3 to the negative Q over 2. Okay, so let's see what we can do with this one. So I've got a couple logarithms in, and why did I bring in the logarithm at all? Well, I bring in the logarithm because, much like Peter Pan, when you take the logarithm of something, that exponent can come down in front. That's one of the laws of logarithms. So I've got log of 18.53 all over 50 equals negative Q over 2 log of 3. Okay, there's a lot of stuff, and a lot of people would go blah, 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 blah. What do I do? Well, keep in mind what you're trying to solve for. Remember where you've got multiplication. I'm going to go ahead and just like an onion, I'm going to start peeling stuff away from the cube. So first thing I'm going to do is I'm going to divide both sides by a logarithm. And I know this is horrible. This looks scary. This looks, you know, like something you wouldn't necessarily want to do with your life. But the good news is the calculator is actually going to be doing most of the work. So we just have to write it all out. So the logarithms cancel, these log of 3, okay? And then I've got log of 18.53 over 50 all over log of 3. Now, some folks who really enjoyed, I know, I hear you laughing, even though I'm recording this well before you'll see it, but I hear you all laughing when I say that. But some people who really love the law of logarithms will try to combine these. Do not do this. When you're dividing two logarithms, you just got to do it. There's no nice way to rewrite it easily. I'm going to look at this and I'm going to say, well, you know what I really need? I need to get rid of this minus and I really need to get rid of this 2. So on both sides of the equation, I'm going to multiply by a -2. A -2 times a -1/2, the 2's will cancel. Another way to look at it is if you prefer, you can do it -2 over 1. Okay, so I've got -2 times the log of 18.53 all over 50 all over the logarithm of 3 is Q. Okay, awesome. Oh my goodness. So say nice words to your calculator because it's about to do a lot of work for you. Okay, so here we go. I'm going to multiply by -2. And again, remember, use the, oh, you can't quite see it. There we go. Use the negative sign, not the minus sign. So -2 times, and then I'm going to put in parentheses. You don't necessarily need all the parentheses I use. I over parentheses cease my work because I get nervous about what my calculator understands. So if I were, you know, slightly smarter, I could probably figure this all out. But I tend to use parentheses all the time. So logarithm, extra parentheses will not hurt your calculator. You just have to close them all. So log of, see how it started a new set of parentheses? So I've got 18.53 divided by 50. That's inside the parenthesis. And then set another parenthesis outside. Remember, that was outside the logarithm. And I'm going to do the denominator divided by log, and it automatically says of what? And I say of 3, close parenthesis, fingers crossed. If I could cross them, they're not crossing right now, fingers crossed. We got a number. I'm so excited. 1.8070 something or others is what quantity is. Oh my gosh, guys, we got an answer. Who knows if it's the right answer, but it's an answer. Yay, an answer. Syntax error is like the worst. So at least this doesn't say syntax error. Okay, so, oh, mirrors are so fun. There we go. Okay, so how many units to the nearest 1,000 units? Now notice I'm not asking what Q is. Q is 1.8, but remember that's in thousands. Will be demanded. So I need to round to the nearest 1,000. So Q, if Q is 1.8070 ... that means the quantity demanded is 1,807 ... units. Right? Because this is in the thousands. And if I'm going to round that to the nearest 1,000 units, that's closer to 2,000 than it is to 1,000. So I'm going to go here and I'm going to choose 2,000 units. Yay! We're 20% done with the test. Woohoo! Dance party. And in fact, that's the only problem from chapter 5 on this test. So we're done with the chapter 5 portion of our test. And we're going into the chapter 6 portion. Now, this first one, I'm not going to say that I think any of the problems are easy, but I think this is the one that you probably have the most practice with. This is just calculating the different compound and simple interest formulas. So this is from the very beginning of chapter 6. And again, you will be given a sheet, something like this, to help you remember the details of the formulas. You just have to recognize which is which. So first, let's take a look. You have $5,000 to invest. Congratulations, that's awesome. Calculate how much you would have after 40 years. This is a long time to invest. If you invest the money in an account earning ... First one, 7% simple interest. So you're going to have to look here for simple interest. I can recognize it here because it doesn't have an exponent. This is simple interest. Notice that this formula also is simple interest. I've given you both forms of it, depending on which one you prefer to use. And again, the sheet that I give you during the test will not necessarily be the same sheet. So don't just memorize which is which. Make sure you're able to recognize each formula. So let me take a look. It says calculate how much you would have after 40 years. That tells me that I'm looking for S, future value, and not just I, interest. If I were looking for interest, it would say how much interest would it earn? And then it would just be this part, the I part, the PRT. If it says how much you would have after 40 years, to be honest, I just copied what Webassign wrote from the book so that it would be the same. I wanted to make sure I was using the same wording. It means we're looking for the full value, S, the principal and the interest. Okay, so I'm going to go ahead and I like this formula. So let me go ahead and plug in the values. My P is 5,000. That's what I'm starting with. And then I've got 1 plus, and we're doing 7%. Bleh. And then it's 40 years. Remember, with simple interest, we don't have to worry about months or weeks or anything. We're looking at just the years. So let's see. 0.07 times 40 is 28. So this is going to be 5,000 times 1 plus 28. So this is 5,000. Oh, I'm sorry. 1, not plus 28. For a moment, I lost it. I was like, no, that's not right. No, it's 2.8. Thank you, guys. I heard you all gasp. It's a mistake. So 1 plus 2.8 is going to be 3.8. So we're basically going to make the whole thing almost 4 times, right? So we're going to end up with almost 4. So our interest is 3 times the original amount. So let's see. Let me go ahead and do the whole formula. So I'm going to do 5,000. Oops, sorry. Get out of the light, Carol Ann. Go into this light. There we go. 5,000 times the quantity 1 plus 0.07 times 40. So I'm just doing the whole formula again just to make sure. And I get 19,000, which is this one right here. Woohoo! So we're off to a great start. Yay! Next up, we're going to use our formula sheet again. And we're going to take a look. And I've got 7%, and this is compounded monthly. So we're looking for compound interest, but monthly. So I'm looking down here, and I've got a couple of options. There are a few. This was an early version of compound interest, which you can technically use, although I think these two are the ones that we tended to use more. These are compound interest. How do you recognize them? Well, you've still got that 1 plus, right? Because you've always got the principal, and then you've got the interest that you're earning. In this case, when it's compound interest, you do have an exponent. Now, simple interest does not have an exponent. Compound interest has an exponent, and this one I think is easiest to see. You're dividing by, in this case, it's going to be kind of brutal and ugly. It's compounded monthly, but 7%. So you take 7%, divide into 12 months, and see how much interest you earn per month. Okay, so it's going to be this. Oops, sorry, you can't see. It's going to be this formula that I'm going to use. Pardon me. So S equals P times 1 plus R over M to the MT. Okay, so I got $5,000. 1 plus interest rate of 7%, written as a decimal, divided by 12. And then up here, I'm going to do 12. 12, so it's monthly, so it's 12 times a year times 40, which is actually going to be 1 plus 0.07 over 12. This is not going to be pretty. To the 480th power. Ooh, this is going to be a lot of interest. Now, keep in mind, we're expecting more than 19,000, right? Because that would be the simple interest version. But how big it can get, I mean, these are some big number options. That would be awesome if we could earn that much money. So I've got, ooh, move this up again. Okay. Ooh, you can see all the cables. Ooh. Okay, I'm somebody needs some more sleep. I'm not going to name names. Okay, so we got 5,000 times the quantity. 1 plus 0.07 divided by 12, close parentheses, exponent. And here, I hear you saying, oh my gosh, what if my calculator misunderstands? And the answer is order of operations. All calculators will understand this with the exception of Casio. Some of the new Casios have some interesting order of operations choices. So if your calculator is a Casio and it's newer and it's giving you weird answers, let's talk. Show me the calculator. Let's figure out how to talk to it. It speaks a slightly different language. Exponent to 480, fingers crossed, and I get, what is my answer? My answer is $81,227, 0.2745. Okay, so this tells me round to the nearest cent. So I'm going to this position. The next digit is a 7, so I'm going to round up. So I should have 81,000. Did I? Oh my goodness. Oh, thank you, reversal brain. Don't you love it when your brain tells you different numbers? It's awesome. Okay, here we go. So those were not 2s, those are 5s. I'm so sorry, I couldn't hear you screaming from the other side of the monitor. Okay, so this is 81,557, and also, oh my goodness, well, at least I was consistent, right? All my 5s became 2s. Sorry about that. Sometimes that happens. And you just move on, right? Same thing though. I've got $81,557, and since this is a 7, I'm going to raise this up to 6 cents. 81,557.06 right there. Woohoo. And that's amazing, isn't it? So if you could get, now this is not a small amount of interest, 7%, especially right now when I'm recording this, that's a lot of interest. So you're doing something interesting, perhaps putting it into some really cleverly considered stocks or other instruments. But, and you're leaving it in for 40 years, which is, it's unusual to have such a consistent return, 7% return over 40 years. That's, you know, a lot can happen in 40 years. But if you could do that, at the end of 40 years, you'd have 81,000, which is really amazing. As long as we don't talk about inflation, it seems amazing, right? Let's not talk about inflation. Don't burst my bubble. Okay, last one. Now, this one is the one that really stresses people out the most. But in fact, this one's not that bad. Compounded continuously is easy to see. If you look at the formula sheet, it's the one with E in it. It's the only one with E in it. That's continuous compounding right there. It's the shampoo. S equals PERT, P-E-T-R-T. Okay, so I've got 5,000 times E. Remember, E is a number. So your calculator has it memorized. You don't have to plug anything in. I've got 0.07 and I put in 40. It's very similar to the formula for simple interest in that there's nothing else to calculate. You just put everything in. There's no dividing by 12 or multiplying by 100 or anything exciting like that. So in my calculator, I'm going to do 5,000 times, and in a lot of calculators, you don't have to do times. I do because, again, I'm old and I can't help it. On my calculator, E is a second, so I do second and then natural log, and that gives me that e to the x. And notice that I get parenthesis, and this is good. So I'm going to take 0.07 times 40 and make sure that whole thing is part of the exponent. Equals, and then I get 8. Let's see if I can actually read it. 223.23386. I look at this digit and I see that this digit is below 5, so I just cut this all off and I get $82,223.23, which I see right there. Yay! Yay! And the good news is that now you are halfway done with your test. Woohoo! And hopefully we're more than halfway done with the video, because otherwise this video is going to go on forever. Oh my goodness. So the last 2 problems on this are going to involve mortgages. So the good news is they're both going to involve the same concept. And remember that when you're talking about a mortgage, you need the full value now and the payments later. So you're not saving up for something. You are looking at the value of the house now and then use payments to pay it off. So with mortgages, this is a present value. So on my formulas, let me see if I have the other. Do I have the other formula sheet that I can show you? Yeah. So unfortunately, I don't have all the formulas on this one. But 6.4, and this is that formula we talked about in 6.4. 6.4 talks about present value of an annuity. So you have the value of the house now, and then you pay it off over time. This is the formula A equals R times this, that mess. And but that's not the format we wanted in. So let's take a look at our options here. Put this there and put that there. So first thing is we're talking about present value, which in this book and in this class is A. Remember, S is future value. So first things first, we're in A land. We're in present value land. And so, oh, there. Oh, I wasn't even thinking. There it is in 6.5, the format I wanted. So amortization, killing off a loan for your mortgage. This has it written the right way, and I wasn't even thinking about that. So yay me, I set this up and didn't remember. So what we're looking at is these two are the same formula. Remember, we have moved the ungodly mess to the other side, which is why it flipped upside down. The important thing here is that this is the formula that has the negative n, or the opposite of n, instead of n. N is future value. The opposite of n is present value. It's kind of counterintuitive. The format I want is the R equals A, because this is the repeated payment, or the payments from the annuity, is equal to the present value times all of this. And you'll notice that that matches this right here. So this is the mortgage formula. Okay, so we've got that sitting there where you can see it. I've decided that you're doing really well. So you're buying a $2.3 million house. Let's see, just for fun, how much it's going to cost per month to pay this thing off. So we've got a couple things. We've got the value of the home is $2,300,000. Okay, we're going to pay 10% down. So what we're going to do there is we're going to take $2.3 million and multiply times 0.10. And that's going to be $230,000. So first off, I'm saying you just happen to find $230,000 in your wallet one day. Like, what a great day, right? So you've got this much. So that's your down payment. So you don't have to amortize this. So the loan is going to be the home value minus the down payment, which is equal to $2,300,000 minus $230,000, which equals, what is that? I could probably do that. And let's see, $2,070,000. Do we trust ourselves? I think that's it. So this is going to be the loan amount right there. That's how much we're going to borrow. And we want to borrow the rest at 6.5%. As I'm recording this, that is a terrible interest rate for home loans. I'm so sorry, because you could have done better. And we are going to do a regular length, so 30 years. And we're going to compound it monthly, which is what we would expect. So monthly payments. And we want to figure out what the mortgage is going to be every month. So I take my formula. Where'd you go? There we go. And this is why I'm going to let you have this sheet of formulas. Again, you've got to be able to recognize which is the correct one. So you're looking for the one that involves A and R and has the opposite of N. And my promise to you is that these formulas will all be correct. I won't give you any formulas that aren't useful. I may give you some that you don't need, but I won't give you any that are actually incorrect formulas. Okay, so I need my repeated payment is going to be the amount of the loan times the quantity I all over 1 minus 1 plus I to the negative n, or the opposite of n, just like that. Okay, so formulas away. And now we got to figure out all these different parts. So our interest rate is 6.5%, which is 0.065. So our interest rate per period is going to be 0.065 over 12. Now, a lot of people would look at this and go, oh, I'll just write it out as a decimal. If you do that, you will make mistakes in this problem. You want to make sure you don't round ahead of time. So we're going to have to use that horrible mess of a number. The other thing we need to know is we know that the timing is 30 years. So n, which is m times t, is going to be 12 times 30 is 360, which is what we expect. There are basically two kinds of common mortgages. One is 360 months, and the other is a 15-year, which would be 180 months. So this is really common. Okay, let's plug all these things in. So I've got this value. And then I've got my 0.065 over 12 all over 1 minus 1 plus 0.065 over 12 to the opposite of 360. Okay, this is very exciting. Shall we get started on this? So this is going to be a lot of calculator work, and I really recommend you practice this on your calculator to make sure you know how to enter it. Godzilla recommends this as well. Okay, so you can multiply by the 2,070,000 in the beginning, or you can multiply it at the end. It's up to you. I'm going to go left to right, so I'm going to go ahead and include it. 2,070,000 times big old parenthesis. Now, here's what I would recommend. I'm going to multiply across the top and set equals. So let me show you what I'm talking about. I'm going to multiply times 0.065 divided by 12. So just straight across the top and hit equals. So that's this much. Now I'm going to divide by this denominator. Divided by big parentheses. 1 minus little parentheses. 1 plus 0.065 divided by 12. Close parentheses, close the little parentheses, raised to the negative 360, close big parentheses. Oh my goodness. You guys ready? Oh, equals, and it gave me an answer, and I'm so excited. Answers are just the best, aren't they? Okay, let's see if I can read them. This one is 13,083.80809 and some other stuff. And again, this says round to the nearest cent. So down here, I'm going to round to 13,083 point. I'm looking at that 8, trying to decide what that number 8 is bigger than 5. So I'm going to go up to 81. Okay, fingers crossed. Is this number, oops, sorry, can you see it? $13,083.81. Oh my goodness, it's right there. Yay! And then let's just pause for a second. That's amazing. $13,000 mortgage per month to buy a $2.3 million house. Whoa. And again, right now, as I'm recording this, interest rates are much, much lower than 6.5%. So you could always, I mean, now that you know how to do this, you could always calculate your dream home and figure out what the monthly payments are. Or you can reverse it, right, using the other formula. Where'd I go? This one, plug in how much you can spend per month and figure out how much you can actually borrow. Woohoo. Right, difference. So this one is a different. It says, if you've been paying $3,059.36 per month on a 30-year mortgage at 8% right now, someone has really taken advantage of you. And you've just finished your 5th year of payments, how much do you still owe on the loan in principal? Okay, so in other words, you're going to refinance because, oh my gosh, someone told you 8%, you could do way better than that. So we're going to look down here, and I'm going to look first at this card I made for the section. In 6.5, where we're doing the amortization, mortgages, we've got the unpaid balance formula. Notice that how similar this is to the present value. We're just looking at what the present value of all your future payments would be. So what do you have to give the bank in order for them to let you out of payments? Well, I guess it's a 30-year mortgage, so 5th year, 5 years. So this is the formula we're looking for. Now, how do you recognize this? Well, unpaid balance has a subtraction in the exponent because you're actually subtracting the payments you've already made. And if you look at the sheet of formulas, there's really only one. It's this one. And again, these may be in a different order. Remember that the unpaid balance formula is the one where you're actually subtracting some of the payments that you've already made. Okay, so I'm going to take this formula and write it down This is the one you'll have access to. 1 minus 1 plus I to the opposite of n minus k all over I. Now, remember this is upside down because, why is it upside down? Why is the I on the bottom now, not on the top? And the answer is because in this case, we're going to plug in the monthly payment and get out the value, the present value, instead of plugging in the present value and getting out the payment. We've reversed everything. So everything is upside down, topsy-turvy. Gotta put away this paper. And so let's take a look at what we need to know. We know the payment because we're given that. We don't even have to calculate it. Wow, that's brilliant. Thank you, Test Fairy. Then I've got 1 minus 1 plus, and I got to figure out what my interest rate is. So my interest rate is 8%. And we're doing monthly payments, so 0.08 over 12. Now, this one you can reduce slightly, but you can't reduce it entirely. Again, it would be a non-terminating decimal. And I don't recommend, because it takes a long time to input an infinite number of digits. It really does. It's going to take most of the day, or maybe the rest of your life and everyone else's lives. Okay, so next up, and this also goes in the denominator. We got everything. There's one step that's slightly harder than the previous problem, and that is you got to figure out what n minus k is. So in this case, give me your calculator, and it's a 30-year mortgage monthly, so it's 360. But k is those 5 years. Let's see, do I have another color? You've just finished your 5th year of payments. So it's 5 years times 12, which is 60 payments. So we're going to have 360 minus 60. So you have finished 60 payments, so there are still 300 payments ahead of you. Depending on what you want to do, you don't have to write this all out. You could figure out what n minus k was right off the bat and not have to write it twice. Okay, you ready for the calculator? My calculator at this point is pretty much steaming from all the use. So, you know, be kind to it. Say some lovely words. Thank you so much, calculator, for being here for me. I really appreciate it. And let's see if we can get to this last calculation and be done with the test. Yay! Okay. 3059.36. So far, so good. Times. And again, I'm just going to go across the top to begin with. 1 minus, another parentheses, 1 plus, and then I've got 0.08 divided by 12. Close the parenthesis. Raise it up to the negative 300. Make sure you use the negative sign. Close that parenthesis. Okay, this is just the numerator. This is not the whole thing. So I've just gone across. Now I'm going to do divided by, and then I'm going to put it in parentheses so that there are no shenanigans, because this is a fraction, and if you divide and don't tell it it's a fraction, it gets weird. Divided by 12. So see that? Put the 0.08 divided by 12 in parentheses, and I get, dun, dun, dun. So let's see, 396,384.5179 and some other things that's not telling me. So then I look to this digit and we're going to round up. So it's $396,384.52, which I see right there. Woohoo. And just for fun, this is not part of the test, and I'm probably going to confuse you, and I will regret this terribly, but you know, you only live once, right? YOLO. So that's how much is outstanding on your loan. You've got 300 more payments. So let's do 300 times. If you just made all these payments, 3059.36, your total payments would be almost $1 million. So at 8%, to pay off $400,000 of loan, you have to make $900,000 worth of payments. So it's a really good thing that you were refinancing. You were refinance at a different interest rate and your monthly payment will go down. Nicely done. Remember, on the real test, there will be an extra credit question. You cannot get this wrong unless you don't answer it. So please answer it. And you're awesome. You made it. It's 45 minutes. And wow, I probably need a nap now. I need a nap to begin with. So on behalf of Godzilla and Sharktopus Dance Party, you guys are awesome. Woohoo. Math on. Make good choices. Have some, vegetables. Get a little rest. And I will see you at the test. Woohoo.